Hi folks, we're going to take a look at page 83, number 17a. Okay, so let's see what they're asking us here. It's saying they're determine the equation or equations of the tangents to the curve y equals 2x squared plus 3 that pass through the point 2, 3. Now at first glance this might look like a pretty simple question. Okay, and there's certainly lots of questions where they give you a point on the curve and they ask you to find the equation of the tangent at that point to this curve. Okay, except here, if you notice, the point 2, 3 is not on this curve. Okay, if you stick in x equals 2, 2 times 2 squared, so 2 times 4 is 8 plus 3 is 11, certainly not equal to 3. Okay, so this is a slightly different problem. So what I'm going to do is I'm going to draw myself a little picture to see if that'll help me out. And again, I'm not really going to spend too much time being precise here. Okay, but I do know that this curve will look something like this. Okay, just a quadratic moved up by 3 units, and 2, 3 is some point here. Okay, and what they're telling me is I'm looking for equations that are tangent to the curve and that also pass through this point. So here, if I take a look at that, I see that, well, it looks like I can draw a line there that's tangent to the curve and passes through 2, 3. But it also looks like I might be able to draw, tangent line somewhere up there that is tangent to the curve and also passes through 2, 3. Okay, so my conjecture would be that there's actually two answers to this problem. Okay, but let's see how we're going to try to solve this. Okay, so we know we can find the derivative of this function. And that'll give us the slope of the tangent at any point. The problem is we don't know what these points are. Okay, if we knew what those points were, it'd be nice and easy to solve this problem, but we don't know what those points are. Okay, so we're going to need to find a way to get to this here. So we know that the derivative is equal to, well, 2 times the derivative of x squared is 2x, so 4x. Okay, and derivative of 3 is just 0. Okay, so this gives us the slope of the tangent at any point. Okay, but somehow we need to relate it to these lines that are passing through 2, 3. So what we're going to use is we're going to use another way to determine the slope of these tangents. Okay, to determine it a little more directly by finding the rate of change between 2 points. So I know 2, 3 is 1 point on this line, and I know that another point on this line will be on this curve. Okay, so I can think of the point xy, but this is where we're going to be a little clever, okay, because I want to try to work with as few variables as possible. Since this point is on the curve, this point can be written as x, and the y value I know is given by 2x squared plus 3. Okay, so what this allows me to do is it allows me to represent any point on this curve with only one variable. Okay, so now what we're going to do is we'll just use the slope formula for any line. By the way, this could work equally well for this point down there, but I'm just drawing this for just to show you what I'm doing here. So here I know the slope of the tangent line is just going to be y2 minus y1 over x2 minus x1, and so here my y2 will just be the y value from the curve, so 2x squared plus 3, and my y1 I'll just take as my y value from the point, so that's just equal to 3, and then here x2 minus x1, well, it's just going to be the x value minus the x value, so x minus 2. Okay, so this is the slope, this is the slope of the line given by just determining the slope between these 2 points, and on the other side I'm going to use my other way to determine the slope of this line. I know it's given by the derivative of my function. Okay, so 4x. So now what I've done is I've managed to create an equation with only one variable. So now I can solve this here. I'll multiply the x minus 2 to the other side, so 4x times x, 4x squared, 4x times negative 2 minus 8x, and on the other side I'm just left with, well, these things cancel out, I'm just left with 2x squared. Okay, bring that to the other side, so what do we have? We have 4x squared minus 2x squared, so 2x squared minus 8x equals 0. and let's factor out the 2x. So I'm just left with x minus 4. So it looks like my x values are x equals 0 or x equals 4. Okay, so just to recap what I did, okay, I used the fact that this tangent line, because it's tangent to the curve, I can determine its slope using the derivative. But because I know it also passes through 2, 3, I can also determine the slope using my old delta y over delta x formula back from grade 9. Okay? And I just equate those two in order to solve. And the trick here being that instead of using just some generic variable y, because this point is on the curve, I can replace y by the equation 2x squared plus 3. Okay? Now, that's sort of the more conceptual part of this problem. Now we actually have to do what they ask us to do, which is to find the equations of these lines. Okay? So here, for x equals 0, so remember, to find the equation of a line, I need a point on the line, and I need the tangent. I need the slope of that line. So here, I can do this in a couple of ways, but I suppose I can find the slopes of these lines now using the derivative. So for this one here, well, y prime is just 4 times x, which is 0. So the derivative is just equal to 0. So that means it's just a horizontal line. So all I have to do is find the y value, but the y value is just given by that point there. Okay, so just to make sure you see what I'm doing, is this ends up being my slope. Okay, the point 2, 3 is on the line, so I can put y equals 3 equals the slope equals 0 times x equals 2 plus b. B is equal to 3, so y equals 0x plus 3 is my equation. So it's just a horizontal line. Okay. Now in principle, knowing that the slope was 0 and it passes through 2, 3, you certainly could just interpret that that's going to be the equation of the line. But just in case you don't see that, I'm just solving it out here. Okay. So now let's use x equals 4. Okay. So again, the slope is just given by the derivative. So 4 times 4 is 16. And now we have a point on the line, which is again 2, 3. So let's stick that into y equals mx plus b. So when y is equal to 3 and the slope is equal to 16, x is equal to 2 plus b. So what do we have? B is equal to 3 minus 16 times 2 is 32. So 3 minus 32 is negative 29. Okay, so the other equation is just y equals 16x minus 29. And there's our second equation. Okay, so I already went through how we got to these 2x values. Like I said, the more conceptual part. And then in terms of determining the actual equations of lines, remember that you need the slope and you need the y-intercept, or any point on the line to